Welcome. My name is Kat Megas, and I am the program manager with the NIST Cybersecurity for IoT program, and I'm here to uh, present today and provide you all with a U.S. perspective on the security of connected devices. Before jumping into the presentation, just to orient the discussion today, I'll not take too long to just give you a background on NIST and the program to provide the context for our work, our role in the overall U.S. perspective. I'd like to share with you some of the drivers from the U.S. on why we need more guidance on securable IoT devices. Then I'll provide you with a quick presentation of what we're doing and what's next. So NIST is a non-regulatory agency within the U.S. Department of Commerce. NIST stands for the National Institute of Standards and Technology. Our mission is to promote U.S. innovation and advance measurement science, standards, and technologies in order to improve economic security and improve quality of life. When it does come to the areas of cybersecurity for federal information systems, we do have a rather unique role. And while we are non-regulatory and the vast majority of our work is not mandatory, and we always take great pride in our work being voluntarily adopted by private industry. In the area of cybersecurity for federal agencies, there is a federal legislation that has been passed and renewed, which requires federal agencies to follow NIST guidance per an OMB memo that's been issued, A130. On the right-hand side, you'll see the portfolio of all the work that we do at NIST related to IoT cybersecurity. And I like to highlight this for several reasons. One is we draw on this broad work when we do develop our guidance. So we do have a long-standing history in working in areas such as IoT cybersecurity. And when you look at our programs, you may not see them labeled as IoT, but nonetheless, they were undertaken in reaction to the needs of IoT cybersecurity. There's work that we've done in standards, and there's work that we've done in guidance. There's work that we've done in areas like lightweight crypto and the needs there, much of that driven by constraints of IoT devices. But there's also areas in the applied cybersecurity that we've done work in. And the National Cybersecurity Center of Excellence, which is housed within NIST, it's actually part of my division, has work in the applied cybersecurity space, which is working closely with industry and stakeholders and the user community, developing and deploying reference implementations, and then publishing practice guides so that anyone in industry or any stakeholder can pick up those practice guides and replicate the cybersecurity solutions we've built out. And our program looking at wireless infusion pumps, which included over 95% of the market of wireless infusion pumps, was published a couple of years ago. Currently, we're working on a program around securing telehealth remote patient monitoring systems. And I think it was just a few days ago that the draft practice guide was published, which is seeking public comment. So again, we recognize that there are network-based solutions as well as device-centric solutions that are needed to address this broad range of IoT cybersecurity. So the IoT cybersecurity program is housed within the Information Technologies Lab, and our purpose there really is to cultivate trust in IT and metrology. And there's been some early work done at NIST to actually identify what do we mean by trust. The Cyber Physical Systems Framework identified 5 aspects of trustworthiness, safety, security, privacy, resilience, and reliability. And part of this is why we do recognize that there will not be one size that fits all, because really depending on the risk and the view of the organization and the use case, what that balance of trustworthiness looks like may be different, and the priorities of those different aspects may be different. And this leads us to a lot of the background and why and how we developed our program principles. So understanding that what we do must be risk-based, that's well established in the cybersecurity framework and the NIST RMF. But we also recognize it's an ecosystem of things. These things do not exist in a vacuum. They exist in a broader ecosystem. And we do embrace the cybersecurity framework approach, which is to operate and establish objectives at the outcome-based approach, primarily because we recognize that there will not be one size fit all, and likely in order to be able to keep up with a rapidly evolving technology, we need to be talking about the outcomes we want to achieve and really allow the flexibility for organizations and the IoT device manufacturers to best determine how to achieve and reach those outcomes. So to dive a little bit into the drivers for our work, there's been emerging state legislation here in the U.S. It was passed over a year ago and took effect the 1st of January of this year. California, Oregon passed those laws. Those laws require manufacturers of connected devices to equip them with reasonable security features. And while there is some guidance provided, this raised a lot of questions from our stakeholders and from the community as to what is reasonable and how can a manufacturer, what can they look to understand what might be reasonable. And it's not just California and Oregon. There's a other draft legislation in place in different phases of the process in my own state of Virginia, but also in places like Massachusetts and Kentucky and Illinois. I haven't caught up lately on the status of those, but those have been in process and are making their way through the system. So when it comes to legislation, there's been a lot of activity at the state level. There's also been much interest from our U.S. Congress. Senate Draft Bill 734 and the House companion to that, 1668, were introduced over a year ago at this point. They were recently passed. The House version passed earlier this year in September. The Senate version passed just this month in November. Those have been sent now to the White House for the president's signature. This bill will cover 2 areas: mechanisms to ensure that federal government agencies procure securable devices. Those mechanisms include NIST publishing the requirements for federal agencies, OMB reviewing policies related to agency policies and identifying if updates are needed for agencies. And then lastly, DHS providing a role in assisting agencies in the implementation of those policies. The House and Senate versions also include mechanisms for coordinated disclosure of security vulnerabilities relating to federal government. Last year, in addition, U.S. Congress commissioned the Cyberspace Solarium Commission for the purpose of developing a strategic approach to defending the United States in cyberspace. They delivered their first report earlier this year, and there were over 80 recommendations made in the report, as well as the follow-on white paper that was delivered a few months later. One of those is to pass an IoT security law. In this case, their recommendation is for the IoT security law to go beyond the current IoT Cybersecurity Improvement Act and pass a law requiring devices have reasonable security broadly, not just those that are going to be procured by the U.S. federal government. It also calls for legislative action to expedite creation of a national cybersecurity certification and labeling authority, and that those should be extended to also include consumer and personal electronics. And last of all, it does call on the need to establish liability for final goods assemblers, primarily in the areas where there are known vulnerabilities and a known exploit, and that there are damages and manufacturers failed to actually adopt better patching practices. The executive branch as well in the U.S. Has put forth a roadmap. We've been executing against this roadmap for a while now. The roadmap that's been established for IoT cybersecurity does not just rely on the government, and neither does the government necessarily lead all of these actions. In many cases, some of these actions are led by private industry, and some of these actions are led by the government. The federal baseline that I'll be talking to you about is a task that NIST led that's been completed. But there's also a call to action on looking at other areas such as labeling and other areas such as conformity assessment, and what do those need to be put into place. And lastly of all, when it comes to drivers, we recognize that we are not the only ones that are interested in the security of these IoT devices. I've listed a couple of here. By no means are these all of them, but there is ongoing work, and as the Institute of Standards as well as Technology, we are concerned about the fragmentation. And while there does seem to be general consensus, there does still remain to be some areas of fragmentation, and we are very heavily engaged in international standards work as a fora to try to at least identify where there can be some common consensus. So NIST IR 8259, we published that earlier this year. This recommends a core baseline in Part A, and 8259 itself proper recommends a framework of foundational activities that we would like manufacturers to use as they consider the recommendations for core capabilities in 8259. 8259A identifies 6 core capabilities. A little background on these core capabilities, and I won't spend too much time on these. All these documents are public. When we started initially, we started out by doing a broad sweep of ongoing efforts, both domestic in the U.S. as well as international. And what we wanted to do was come from an initial starting point of where does everybody seem to generally agree are critical capabilities for IoT devices. And the IoT Security Foundation's guidance at that time was one of many that we did draw upon to actually come out with these initial 6. And we incorporated over 600 public comments, two public comment periods. We had multiple public workshops, and we've seen quite a bit of support for these 6 capabilities. In fact, CTA 2088, which is a U.S. national standards body, just recently released a national standard where much of their work is reflected by this guidance that NIST published in 8259A. So what are we doing next? We have started elaborating on the federal government requirements. As we've been working on that, we identified that there are, in addition to the 6 technical capabilities, there are 4 areas of non-technical capabilities that we think are good recommendations for any IoT device manufacturer. As I mentioned, we are working on also establishing the requirements for federal agencies, which are required, as I mentioned, under FISMA and public law. There's going to be a multi-part. There will be a part to this which will be addressed and towards the audience of manufacturers to help them perhaps understand the starting point for what federal agencies may need, as well as the guidance and catalog for federal agencies for them to consider risk and how would they use the catalog to establish the requirements for IoT devices that they procure. This is a sample of kind of what the draft guidance currently looks like. We will be publishing it in the next couple of weeks, so it will be open for public comment. All of our documents are accessible, and we welcome comments from anywhere. You can. We always prefer that people submit their comments through the comment form, but we will take comments in any way, and we're always welcome any thoughts if anybody would like to invite us and host a roundtable and perhaps give us verbal feedback if that's more helpful. And finally, I just wanted to summarize, this is not the only area that we're working in. We do receive and we do consider a lot of feedback that we receive during workshops. We may not always be able to discuss all the questions if they aren't in the context of the workshop. However, we have been listening, and the feedback we've received and the questions overwhelmingly have led us to kind of starting off 2 new work streams. One is focusing on consumer devices. There was a draft report 8267 that was released that published the results of a security review of consumer home IoT products. We also conducted a workshop not too long ago on cybersecurity risks in consumer home IoT products. And there's also a usable cybersecurity for IoT program that has been launched, and they are conducting workshops and research and surveys to better understand this area. And then the other area that I'd like to call your attention to is really around the confidence mechanisms for the marketplace. This has been an area that stakeholders have been talking to us about probably since the beginning of this work. We did feel we needed to talk initially about the requirements and establish what are the requirements. But now that we're making good progress and the requirements are underway, at least for the federal agency, we want to start talking about, okay, well, what needs to be in place to have that confidence? And this confidence usually follows an arc of defining the requirements, the standards that then meet those requirements, and what is the conformity assessment process that needs to be in place in order to be able to have confidence that if you are the buyer and you've established requirements or identified requirements or a proxy of the buyer, how can you have confidence in the IoT device actually meeting those requirements? So look out for those white papers. Those will be also published shortly, and we will probably be engaging and welcoming feedback and input as we see how those work streams elaborate. So here's my contact information. I think we're going to take questions now. Thank you.